Because you're already getting into rules is what I'm saying with the number, you know what I'm saying? Because it could be, I thought the derivative of negative cosine of x was 17, constant. I don't know, I'm not sure. Hopefully 3.3 will clarify some of this. But here's what I'm going to do. I'm going to change my table. I'm going to start at table, second window, so hit table set. And I'm going to start at 0, and I'm going to count by pi over 2's. And when you hit that, it'll just change it for you. You know what I'm saying, Nathaniel? So that when I check my table, my table is now counting by pi over 2, so I can get the values that I want, Anna. Okay? And now let's go through, let's play our game. Let's play our Math 4 game. You guys ready? At 0, what's the sign?
0.
At 0, what is the sign? What is the y length of this reference triangle? Peepers should be on my arm, and only here. At 0, what's the y length of this reference triangle? What's the sign of 0? 0. Pi over 2, or 90 degrees? 180 degrees? 270 degrees, or 3 pi over 2? 2 pi. Is it matching? Yeah. What you just did was you figured out, using your mathematician skills, that the derivative, if you actually plotted a graph of all the rates of change for every x value for the negative cosine of x function, the actual graph of those values is the sine function. Isn't that kind of wacky? Huh? A little bit. I don't know. It's kind of weird, you know? It's actually a graph. You create the graph that's created when you just plot the slopes at every point. And again, we're just testing the main 90s here. But if you look, it looks like the sine, and it actually is. The derivative, an equation that plots every single x for every x value, the slope of the tangent line for the negative cosine of x function, it is, that graph that you create is the sine function. Isn't that fun?
So like the derivative of cosine of x is negative?
Oh, see, you are just like, you're doing your, give her your hat, Rafi. Give Sonia, she's getting the detective work. Where he gets it. So that's interesting. What happens when you put in negative then? Does it flip? Great call. You can try it. You know what I'm saying? It's a great call. Well, let's take a look at this, you guys. Let's do this first. Let's start a new problem. Okay, I'm just going to look at the sine of x function. You guys see it right here? And by hand, I'm going to sketch. So no calculator this time. Chris, by hand, I'm going to sketch what the graph of the derivative of this should roughly be. Are you guys ready? Okay, let's all do it together. I said, are you guys ready? Yeah. All right, here we go. Now that we're all really excited about this. Okay, so I'm just going to, again, what we're going to do is make a picture for specific x values. I just want to plot the rate of change, or the slope of the tangent line of the original function as a value for specific x values. Does that make sense what we're doing, Estella? Does it?
Yeah.
Okay, so let's start at 0. You guys ready?
Yeah.
Okay, here's 0. Okay, so this function is kind of going like this. What would you say that value is? Yeah, it almost looks like the line y equals x. You see how I drew it there? Right, just at that point. Do you see that? It looks... Do you see it? How I drew that little tangent line in there? Just a little guy. Just a little guy. It looks like it's almost the line y equals x. Almost exactly like the line y equals x. So I'm going to put in the point 1, because the slope of that line is 1. What about at pi over 2? Well, over here, what's the slope of that? 0. It is a ghost. I don't know what that means. What about over here? What does that look like? Again, you guys understand we're just making a sketch of what the rates of change graph would look like for the sine of x function. Just making a little sketch for all the values, like we did on the quiz. You know what I'm saying? Just making a little sketch. So at pi, what does this look like it is? So it looks like it's around -1. What about at 3 pi over 2? So what does this tangent line look like? What's the slope of that tangent line? 0. And back up here? What does it look like? What would be your guess here at 2 pi? What's if I drew a little tangent line? What's it? Yeah, it's like 1. I don't know. It could be 2. I don't know. I'm just going to say 1. 1.5 or something like that. Okay, let's go the other way. What about at here, at negative pi over 2? 0. What about at, so you got to go from left to right now. What about at negative pi? What does the slope of that tangent line look like? Yeah, it's around negative 1. What about here? 0. And what about at negative 2 pi, going from left to right? 1? Yeah. Okay, so I just plotted a couple points where I'm plotting a graph of the slopes of the tangent line, okay? I'm making a graph of the derivative of this function. Michelle, does that make sense what I'm doing here? So if I connect my points, this is a graph, this is my function, this is a graph of the derivative, f prime. Have we seen that before? What is that function? Are you guys just taking guesses? Let's check it.
Wait.
Let's do our check. At 0, what is the x length of this reference triangle? 1. At pi over 2, what's the x length of this reference triangle? 0. At pi, what's the x length of this reference triangle? Negative 1. 3 pi over 2? 0. 2 pi? 1. It sure does look like it's matching up. What does that mean? Yeah, if you sketched a graph, if you wanted to know the rate of change for any x value of the sine function, you would just look at the output for the cosine function. Isn't that interesting? No. I think a little bit, whoever said that. I mean, it's a little bit, you know what I'm saying? A graph that gives you the rate of change for anywhere, Lauren, anywhere on this function, anywhere at all. If you want to know the rate of change for any x value of the sine function, you just plug that same x value into the cosine function, and it'll give you the slope at that point. Isn't that neat? Isn't math fun? Check out a couple more. So let's check out the next one, you guys. So is that the x times absolute value of x over 2? Okay, take a look at it. X times absolute value of x over 2. Okay, now I'm just going to graph the derivative. I'm going to do zoom. I'm going to do a standard zoom. Yeah, do zoom 6. 6 cells on that weird trigger one. It doesn't matter if you had it on. But so this is a graph of the derivative of what does that function look like? Absolute. Did you guys test it? Did you check a couple points off your table? You're telling me that the derivative of this function is this. Did you test it? Did you check a couple points? Okay, well let me ask you this. Where is this function, you guys, where is this function not differentiable? This one. Well, we got plenty of time. Where is this function not differentiable? 0. Everyone stop and listen. Everyone stop. My question to you guys, where is this function not differentiable? And I would disagree with that. What is that a picture of?